Hello everybody, welcome back to the podcast. Today we will be covering 6 very important and special topics. Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, how gravity affects objects, how friction affects objects, and how various types of forces impact the movement of objects. First up, Newton's first law of motion. Newton's first law of motion states, an object at rest will remain at rest, and an object in motion will remain in motion unless an unbalanced force acts upon it. For example, this glue bottle will stay at rest unless acted upon by an unbalanced force, such as me hitting it. Newton's second law of motion says that the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force, and inversely proportional to the mass of the object. A simpler definition for this is the acceleration of an object depends on its mass and the net force exerted on it. The reason that the biker without the backpack accelerated faster is because they had a smaller mass, so the force had less mass to push forward. The biker with the backpack had more mass from the backpack. Therefore, the force had more mass and weight to pull forward, causing it to accelerate slower. Newton's third law of motion says, for every action, there is an equal and opposite reaction. Right now, I'm jumping on a trampoline. This shows Newton's third law of motion. For every action, there is an equal and opposite reaction. I'm pushing down on the trampoline, yet it's launching me back up. This is equal and opposite. Equal because if I push down harder, I'll go up higher. And if I push down lighter, I won't go up as high. And opposite because I'm pushing down and I'm going up. I'm pushing down and it's pushing back up at me. Now we talk about friction and how it affects different objects in motion. It's the force that stops you in motion. Friction is a force that stops objects in motion. And the less friction you have, the slippery something will be, such as wood floors and socks. That has low friction, so high slip. Carpet. I still slide a little bit, but not very much. That's because the friction is higher, so the slip is a little less. And the frictioniest of them all that I have here is very grippy, so there's going to be very high friction and very low slip. See, the higher the friction, the less slippery something is. So ice would have very low friction because you can skate along it. But concrete has a higher friction. That's why you can't slide. That's why we need wheels. Next, we're going to talk about how gravity affects the movement of objects. If I throw this charger block, it's going to go in a curved path due to gravity. If there was no gravity, it would go in a straight line wherever I threw it. But there is gravity, so it'll go in a curved path in the direction that I threw it, and then it'll get pulled back down by gravity. Did you see that? This curved path that it's taking is called projectile motion. It'll go straighter. A little too straight. Next, we're going to talk about other forces and their effect on objects' movements. Next, we're going to talk about applied force. This is the force you use when you push something or pull something. For example, this is applied force in that direction because I'm applying force and making it go, and making the object move. Next, we have normal force. Why isn't the pillow falling through the box? Normal force. That box is pushing back up on the pillow. That's the same reason why I'm not falling through the ground. The earth is pushing back up on me. However, if I put this exercise bike on the box would break because the normal force cannot support that, but it can support me.
Thank you for tuning in for this episode of the podcast, and I hope you enjoyed and learned. Keep educating yourselves.
I woke up in a new Bugatti. I woke up in a new Bugatti.